Okay, now that we've gone through all 12 functions, we just want to answer some questions that relate together all of this vocabulary that we've been learning. And so in number 1, 9 of the functions have domain of all real numbers. Which of the 3 do not? And so this is a piece of paper that I posted on Google Classroom. You're allowed to print this out or have it with you whenever you are taking a quiz or a test. That way you can see what the graph looks like just real quick. And so which of the 3 do not? You could actually have answered this question back in section 1.2 because we talked about which 3 functions have a restriction on their domain. Those 3 functions would be, first of all, the square root function. So right here, and I'm just going to write it out in words, but you could also do it as an equation if you wanted to, the square root function. Okay, the next one is a denominator, and so that's going to be your reciprocal function. By the way, you're not going to want to write on your gallery of basic functions. I'm just doing that because I'm going to have a fresh copy on every slide. And so the reciprocal function. And then the last one would be the logarithmic function. And remember that argument has to be greater than 0. Okay, question 2 is similar. It says, which functions have no negative numbers in their domain? And then of those 2, so that's kind of a hint there that there are going to be 2 of these, which is not defined, which is defined at x is equal to 0. So let's start with the first question. Which functions have no negative numbers in their domain? Well, that would be the square root function. That would be the first one. And the second one would be the natural logarithm function. So I'm just going to put logarithm. Okay, now of those 2, which of them is defined at x equals to 0? So what that means when we say defined is that it's in the domain or that there is actually a point at x is equal to 0. So if you look at the graph of the square root function, is there actually a point at x is equal to 0? And the answer to that is yes. And so the square root graph is defined at x is equal to 0. Is the logarithmic function defined at x equals 0? And the answer to that is no, because we have a vertical asymptote at x is equal to 0. So this logarithmic function is not defined at x is equal to 0 because of a vertical asymptote. Okay, question 3. Which of the 3 functions are bounded? And so remember, that word bounded is an all-encompassing word, meaning bounded above and bounded below. And so if you look at your functions, just go through them one at a time, see if you can find the ones that are bounded both above and below. And hopefully you came up with the sine function, the cosine function, and the logistic function. Those are the 3 functions out of the 12 that are bounded. Now there are some other functions that are bounded below. So for example, this quadratic function is bounded below. The square root function is bounded below. The absolute value function is bounded below. But the question didn't ask bounded below, it asked bounded, and you have to remember that means above and below. Question 4, we want to know what 2 functions have points of discontinuity, and are those points actually in the domain of the function? So remember, discontinuity means that we cannot draw the graph without picking up our pencil. So if we look through here, f of x equals x, we can draw that without picking up our pencil. Same thing with quadratic, same thing with cubic. The absolute value can be drawn without picking up your pencil. The reciprocal function cannot be drawn without picking up your pencil. You have to pick up your pencil at x is equal to 0 in order to keep drawing that function. So the reciprocal is one of them, and it has a point of discontinuity at x is equal to 0. Okay, let's keep going before we answer the second question. Square root is continuous on its domain. Exponential is continuous on its domain. So are logistic. So is natural logarithm. Sine and cosine are very continuous. This guy right here has a bunch of points of discontinuity. So the integer function, or the greatest integer function, if you want to call it that, has points of discontinuity at all integers. Now, which of these points is actually in the domain of the function? Well, remember, the domain of the reciprocal function is negative infinity to 0 and 0 to infinity. And so 0 is not in the domain of that function. So I'm just going to say here, not in the domain. For the integer function, the domain is all real numbers. So even though it has infinitely many discontinuity points, all of those values of x are actually still in the domain. So I am going to say yes, those points of discontinuity are still in the domain of the function. And so if you have any questions about that, please feel free to let me know. This is almost entirely about vocabulary. Okay, final question for your notes here on the 12 basic functions. Which of them are even? And so remember, what does it mean for a function to be even? It means that we have symmetry to the y-axis. And so the three functions that are going to have symmetry to the y-axis will be your squaring function, or I just call it the quadratic, the absolute value function. Whoops, let's see if we can spell absolute value. And then the last one, little hidden, but you can see down here, okay, especially if you look on your paper, that the cosine function is also symmetric to the y-axis, which makes that function even.